Hi, everyone. Thanks for joining us this morning for our tips for expanding how you teach Boyle's Law. In a moment, I'll pass it off to our presenters, Nüs and Melissa, but I wanted to just go over some housekeeping items while people are joining us. So we'd love to answer your questions during the session, so please either put them in chat or Q&A. We'll be monitoring both of those. If we happen to not get to your question during today's session, we will definitely follow up with you afterwards. And in a few minutes, I will put a link in the chat to a shared folder that has additional resources for the experiment that Nüs will be going over and other tips and tricks, excuse me, as well as a certificate of attendance. And you'll also get a follow-up email with the recording link to the webinar and also the link to that shared folder of resources. So again, feel free to put questions in Q&A or chat. We'll be monitoring both of those. And with that, I will pass it over to Nüs and Melissa.
Hi, folks. My name is Nüs, and I'm going to be helping with the webinar here today. And then my colleague Melissa is going to be trying to answer questions, and whether you put them in chats or whether you put them in Q&A. And so I taught chemistry and physics for 34 years in Maryland, and I've used Vernier stuff since 1984. And so it's been an interesting journey as far as Vernier. Let me get this thing. Does this thing go? Oh, there it goes. Okay. Melissa, do you want to say a little bit about yourself?
Sure. Yeah. Hi, everyone. Welcome. I'm also one of the chemists at Vernier. There's 3 of us. So if you guys in the audience ever call and ask to speak to a chemist, you're going to get me, Nüs, or our other colleague, Elaine. So we are the chemists in the office. We help develop the products, write the curriculum. We do all these trainings. So we're happy to be here today. And like Nüs said, I'm going to be monitoring chat and Q&A. So if you have any questions or have any goals, specific expectations out of today's webinar, please throw them in there and I'll answer you or interrupt Nüs and make sure he addresses it.
Yep, I look forward to that. So sounds good. All right. So the title of the webinar was Boyle's Law, but I'm going to go a little further into it and look at some of the features of things you can do that you may or may not be aware of. And then we are going to use Graphical Analysis Pro. So if you have not installed Graphical Analysis Pro on a separate device and you want to play along, my suggestion is go to vernier.com and download the free version of Graphical Analysis Pro. Put it on your phone or put it on a tablet or something that you're not watching the presentation on, and you will get to play along. You're going to get live data from me, and then we'll analyze it together and we'll look at some of the features of GA. So just a little note about pressure sensors. We have a number of different options. I'm going to be using the Go Direct gas pressure sensor today. But you can see we have you could do this exact experiment. You could do it with all of them, but these wide range pressure sensors that go up pretty high, they're kind of designed for your own specialty plumbing. And so they don't come with the syringe and things like that the other ones come with. But yeah, we do have a number of options in terms of pressure sensors. And so a little expectation, what are we doing today? Well, we're going to do events with entry data collection, which is a little different. If you haven't done it before, might be something that you might be curious to see how to do. Events with entry is commonly used in things like Boyle's Law, Beer's Law, acid-base titration. Those are things that don't collect data against time. We're going to look at data sharing. We're going to look at curve fitting, calculated columns. We're going to linearize the data, and we'll look at how to create reports. And if we have time, we've got the new feature just came out in graphical analysis with error bars, and Melissa's got a neat little thing that she can share. If we have time, I'd love for you all to see that. So anyway, let's get graphical analysis set up so you can get data from me. So the deal here is on a separate device. I mean, you can do it on the one you're watching the presentation on, but then you got to flip back and forth or divide your window. Launch graphical analysis, and you should end up with a screen that looks like this. Okay, that if you don't have the pro version already, if you have the pro version, that's great. But if you don't have it, you're going to get it here you're going to get a 2-week license that you can use with your students. It'll be good for everyone at your school. So launch graphical analysis and you get a screen that looks like that. And then today's license key is these letters right here. So in this box, what you're going to do is you're going to type in those letters. Let me get my graphical analysis up there. There it is. And of course, it's covering up the letters. Let's do that. And caps does matter. VNG LLAP 7E. There we go. So if everything's working right, when I hit submit, it turns my copy of graphical analysis into a pro version, and you can see it's a limited version. It's good for a couple of weeks, but take that license key, share it with your students, explore, and I'll show you a few things towards the end that you might want to look at besides data sharing. Data sharing is what we're going to use in a minute, but lots of other things that you can do with it. So let's see here. So on your copy of graphical analysis, what I need you to do is I need you to get into the data sharing mode. And so if your screen, after you entered that license key, if your screen changed, you need to do a new experiment. Okay, so tap on the file icon, top left corner, looks like a little piece of paper, and then do new experiment. You should end up with a screen that looks like the bottom part here, and tap on data sharing. And I need you to stop at that point. You want to make sure that your screen looks like this, that you're online. Let me get my my iPad over here. And so you guys can see. So on your end, oh, I never installed the key. Let's do that. VNG capital L, and then AP, and then 70. I guess I could have done this in advance, but you'll. All right, let's see if I typed it in right. So on your end, I want you to tap where it says data sharing if you haven't done it already, and leave it like that. Just leave your screen just like that, okay? And because you're going to be getting data from me. What I'm going to do is I'm going to set up graphical analysis for events with entry data collection, okay? So let me bring my copy of graphical analysis up. We'll have both of ours up here. Let me get, there's you. So that's the way your screen should look. My screen, I'm going to be the source of the data. And so my screen is going to be a little bit different. What I'm going to do is I'm going to tap where it says data, sensor data collection. And let me get a camera up here so you can see the actual sensor. So here's the sensor. These GoDirect sensors are kind of cool. They don't need an interface. They can connect by Bluetooth wireless. They can also connect by USB. They do come with a USB cable. It serves two purposes. You can collect data through the cable. You would also use this cable to charge the battery if you're going to run this thing by Bluetooth. So I charged mine up last night, so I'm going to tap the power button and an LED should start to flash telling me that it's ready to connect. So what I'm going to do is connect that sensor to my computer. So I'm going to do sensor data collection. It's going to look around and say, what do you got? Oh, there it is right there. There's a unique number on every sensor. If you had a bunch of these in your classroom, the students would have to look for the last couple of digits of that number to make sure they connect. Bluetooth is a one-to-one connection. So once I'm connected to it, you'll notice that the LED, it's hard to tell on the camera, but it's now flashing green. And it's no longer available down here. We get this question all the time. How many devices can you connect to a GoDirect sensor? And the answer is really easy. Well, one. So anyway, let's get back to the experiment.
And I want to say something real quick here, because I know a lot of people are like current Vernier users, maybe have some of the corded gas pressure sensors or want to use their Go Direct one via USB, if you connect those hardwired in to your computer or Chromebook or whatever, it'll automatically recognize it. So you don't have to go through that setup. Just in case you have an interface and cabled sensors, you can do all this same stuff with graphical analysis.
Yeah, if you connect it all before you launch graphical analysis, like Melissa said, boom, your screen will look just like mine right now. And you don't have to go through all that connection stuff. The Bluetooth, you need to go through the connection stuff for Bluetooth. But I kind of like it because look, Mom, no wires. You know? All right, so let's see. It's set up for collecting data time-based. I want to collect data pressure against volume. I want to be able to tell the system how much volume of gas is exerting the pressure. So on the bottom left corner, I tap where it says mode, and it gives me some options here under mode, some different options for different types of data collection. We're going to do event-based data collection. The event is going to be called volume. If you're a purist and you're talking about gases, you might put cc's in here, but the experiment file that I shared with you and the syringe is calibrated in milliliters, pretty similar, especially for water. So I'm going to stay consistent with that. And so this is done. And now you'll notice that there's another button up here. And I've got a data table, and I personally, there's a little itty bitty meter down here, but I personally like to turn on a larger meter. It just makes it easier to see what's going on. So under the view options menu, top right corner, you can turn that on or off at will. Okay, let's get you collecting data. So I'm the source of the data. So up here at the top of my screen, there's a little TIE fighter, right? This little icon, it's the data sharing icon. I'm going to tap on that, and I'm going to give you a code to connect to my computer through the internet. So I'm going to start this session, and let me zoom it up here a little bit so it's easier to see. YUX9TR. Notice, and I'm going to do them, that it's all lowercase. This is actually, a lot of us asked for this from our software guys, because if you're on a tablet like I am, what a pain in the neck to have to go up and down and capital and blah, blah, blah. So the software guys, and we're trying to get away from things like I's and ones and things that are easy to mess up. So once you've got that in there on your end, tap connect, and Shazam, look at your screen. It says pressure and volume, right? And so we're kind of ready. I'm going to go ahead and, well, I'm not quite ready yet to collect data. Let me go ahead and show you the setup here. Pressure sensor comes with a whole bunch of accessories. Highly recommend you don't give this bag to your students. It will never come back the way you gave it to them. Look at all those little bits and pieces in there. They're going to end up in the sink. They're going to end up on the floor. And they don't need it for this experiment. The only thing they need is the syringe. This is a great experiment for setup because it's just the syringe. So what we did at my school is we put all these accessory bags in one of those plastic, shoe boxes or whatever, and then pull out what you need for the experiment you're going to do. So what I'm going to do is I'm going to take the syringe and I'm going to set it to 10 milliliters. So I've got 10 milliliters of air in here. I'm going to connect that. Number one repair on a pressure sensor is this lure lock connector, because some student usually muscled the heck of this on here. We repair them for free, but the issue is that you don't have it while we're trying to repair it. So, that's one of those things where don't go crazy. It's plastic. Okay. So I'm going to start collecting data. And you should see on your end, let me get my iPad up here. Notice that it's on your end, it should say collecting. Now it's waiting for me to do something. Let me get my iPad out of the way because I don't think we need it anymore. I've got 10 milliliters of air trapped in the syringe. So I'm going to tap on keep, and the system says, well, what's the volume of gas? 10 milliliters. So I'm going to put that in. Okay. And so I'll keep that point. You should now have a point on your screen. Are you guys getting this? Give us a little high five or something. Okay. Let us know that you're getting it if you're following along.
I'm getting it, Nüs. It's all happening.
Yay! Yay! Okay.
But you might just to verify, sometimes those little points are hard to see. So if you've connected, you might want to turn on your data table or turn on your data table like Nüs showed in the beginning. And then that way you can see the data coming in. It's a little bit easier to see than those little tiny dots. It's just
tap on
a
this
hint.
view. This icon at the top here, the view options, and then turn on the data table. And that way, as the data comes in, hit it again there we go. And you can see that it's starting to come in. Okay. So now, honestly, there's no rule about how to do this. It's really a great experiment to do with two people. We'll see how good I do here. I'm compressing this to 5 milliliters, holding it as steady as I can. I'm going to tap on keep. Now, the neat thing is, once you tap on keep, you can relax. Pardon me, because it's grabbed the pressure. It's just waiting for you to tell it what the volume is. So I got that point. Let's go the other way. I'm going to go all the way up to 20. So I'm going to hold that thing as steady as I can. Try not to, with one hand, it's really easy to bend the plunger. So I'm going to try to keep it straight and tap on keep. Relax, 20. Okay. And then let's put a few points in between. So let's do 15. I mean, in the classroom, you might want to have them do a number of points, just so that they have, a little more data here. 7. I remember when I first started teaching, I did Boyle's Law with bricks. Anybody in the audience do Boyle's Law with bricks? Okay. I still use
the school books, the big school books, textbooks.
Yeah.
Textbooks.
I use bricks, but school books would be fine. Yeah. But yeah, I mean, it was just goofy, kind of. And then I had the students measure the diameter and calculate the pressure, because you had to weigh the books. And, all right, where am I at here? I'm talking and doing this. Hopefully I'm not screwing our data up too bad. We'll talk about that too here in a bit. That doesn't look good. What did I just do? Ooh, that data point. Hot. We might have to recheck that one. That one's a little weird. Oh, you know why? I was doing 13 and I typed in 8. Perfect. Keep that in mind. I'll do one more. I'll do 18, 17. I'll do, yeah,
good 17. Example. That's
a good example of boo-boos, yeah. And boo-boos, are, unless your students are perfect, I'm sure all you guys students are perfect. They're going to make a mistake. Okay, so here's the deal with Vernier stuff. So once you're done collecting data, then you would tap on stop. Now, there's a couple of things to think about here. Like my students, I would tell them, don't tap stop until you're finished. And then they would, go, oh, Mr. Hism, I forgot I need to do more data. So they would tap collect, and then they got these 2 choices. And the big green one looks like what you want, but if you want to add data to your set, of course you would append. Some of my students didn't know what append meant, but you can do that, obviously. New data set would obviously put the data in a separate data set. We don't want that. Okay, so let's go back to the first set. The other thing that I wanted to look at was the data itself. I made a boo-boo, right? Like right here, I've got a data set that's, let me see if I can get rid of that one data set because I was talking and let's see if I can, this data set cannot be undone. Okay, probably because I don't have anything in it. Okay, anyway, let's get back to it. I typed in the volume of 8 here, and I meant to type in, well, I should have typed in, I believe it was 13. And so the way Vernier, all our software works is any data the students put in, they can change. They cannot change data collected by a sensor, however. So they can't change the pressure, but they can change this. So let me see how 13 looks. I think that was the right volume. Yeah, that looks pretty good. And so you could go in and change that. For now, in graphical analysis, if you want to delete a data point, if you don't like it, just delete the one of the, this one that you put in, and it'll just disappear from the graph. At some point, there will be a strike through option, but that hasn't quite come to fruition yet. All right. Now what I want to do is I want to give you an opportunity to try the data analysis with me. And so what I'm going to do is I'm going to disconnect from you guys. So anyone that's connected to me, I'm going to go up here and I'm going to stop sharing, because I want you to experience some of the analysis options. So one of the things that some teachers have told us about this data sharing option is that even in the same classroom, if you had a bunch of students who were working, like say in a group, maybe say 3 kids in a group, one could be connected to the sensor and collecting data, while the other 2 could be sharing that data all at the same time in the same lab group. And so you don't have to be, thousands of miles apart to do data sharing. You could do it right there in the classroom. But that is a Graphical Analysis Pro option. So just be aware of that. Okay, so we're teaching Boyle's Law, and I think most of us are somewhat familiar with Boyle's Law, and we know that this pressure should be inversely proportional to the volume. So let's see if we can prove that. So we're going to go down to the bottom left, if you're following along, bottom left to the little graph options icon, looks like a little itty bitty graph. And we're going to tap there and we're going to do a curve fit. Okay, so if you're following along, tap on graph options and then tap on curve fit. Linear always comes up first because it's so common. It's, we use it for many changes, but in this case, obviously our data is not linear. So if you tap on the box where it says linear, you can pick any fit you want. And I would suggest, don't tell your students what the relationship is. Let them find it. It's not proportional. It's not linear. Is it quadratic? Sort of, maybe. Is it a power fit? Ooh, that looks a little bit better. It's up to you whether you want to tell them to use inverse or not. But, I like the power fit, and you'll see why here in just a second. Okay. So I'm going to pick the power fit and I'm going to tap apply. And you look at this and you go, well, Nüs, y equals some constant times x raised to the, well, in this case, -1 is what it should be, but it's 0.9. And, is that error? Yeah, it is. It's human error. It's actually an error we know about. Okay. And let me show you what I'm talking about. So I went down to the repairs guys and I got a dead pressure sensor so I could take it apart. By the way, this picture is in the PowerPoint, so you can download it. If you look at this is the actual sensor right here, and there's a piece of tubing that runs to the Luer lock connector. All the air that's in that is unaccounted for. That air, it's about 0.8 milliliters. That's unaccounted for. Now, what we could do is we could go into graphical analysis and just, re-enter those numbers and add 0.8 to it. But if you know me, I like to talk in rhetoricals. Wouldn't it be nice if we could have graphical analysis add the 0.8 for us? So if you're following along, right next in your data table, right next to where it says volume, tap on the 3 dots, and let's put a calculated column in there. Okay, so 3 dots next to volume. We'll do a calculated column. This will be the corrected volume or adjusted volume or whatever, volume 2, whatever you want to call it. Units are still the same. But what we want to do now is take the original volume and add 0.8 to it. So if we tap on insert an expression, okay, we need to find something that, is going to take X, the variable, and add a constant to it. Oh, there it is right there, X plus A. Okay, so that's going to work well for what we're doing. So I'm going to pick that. Now, one note. Notice that since I picked the 3 dots next to volume, it automatically put volume in for X. The students were, for some reason, to pick pressure, the 3 dots next to pressure, it would have put pressure in here. And so if you tap there, any variables that are available, they will pop up. Okay, so but if you pick the column that you want to do the manipulation on, then then it should fill it in properly. And this is 0.8, not 1. It always fills in a 1 for the constant. But you can obviously change it to what you want. So I'm going to put 0.8 in there for the corrected volume. Let's tap on apply. And you go, well, Nüs, it didn't change anything. Down here on the x-axis, tap on the label and change the x-axis to corrected volume. All right, drum roll. The B value should get close to -1. Let's see how I did. Boom, baby. 0.999, 3 nines. That ain't bad, right? And so by doing that, so yeah, could you do this with Excel? Of course. Could you do it with Sheets? Of course. Could you just go in there and type the numbers in? But I worked with a teacher last night on AP Chem Experiment 1, the sports drink lab, and all those manipulations in there. I showed her, you can do them all. You don't have to export to Excel unless you want to. But yeah, look at that. Very nice. So this is showing that, pressure is inversely proportional. Well, what is the constant? Common thing that we teach is P is inversely proportional to V, or P is equal to some constant divided by V. So what would be nice is if we could linearize this data and if we got a linear plot, then we could look at the slope of the line, and that would be our constant. So I'm going to do the same thing again, and you're welcome to follow along. We're going to take the corrected volume and we're going to do the inverse of that. So tap on the 3 dots next to corrected volume, do a calculated column. This time it's going to be 1 over V. You can call it inverse volume if you really, really, want to. All right. And then let's go find an expression that will take our corrected volume and do the inverse of it. So let's see what we got here. Looks like the second one here will do that just fine for us, A over X. Okay, that'll do what we want. So let's pick that, take a look and see what it looks like. 1 divided by the corrected volume, right? And once again, if the students happen to pick the wrong column to start with, it's fine. Just tap on there and you can choose the correct variable that you want. Okay. And so I'm going to tap on apply. And once again, it's like, that's pretty boring news. Let's change the corrected volume on the x-axis to 1 over V. You will notice that, now, that looks pretty good. One-handed in near Portland, Oregon. How did he do? Let's find out. Let's do a linear fit. So go to the graph options. Once again, we're picking a curve fit. Okay, but this time we are going to use the linear fit because we linearize the data. So let me get this back over here to the first set of data. And so we'll do a linear fit and I'll apply that. And once again, drum roll. Let's see what my correlation coefficient is. 4 nines correlation. I'll take that. Left-handed, and I'm not feeling really well today in Portland, Oregon. Not bad. Okay, the R value tells you how good the fit is. Best value you can get there is a 1. And so sometimes the statisticians will call this 4 nines correlation. So pressure is equal to some constant, in this case 1088. I know you purists at Love Logger Pro, they're talking about putting units on here. I don't know if and when that's ever going to happen. It is important for like AP classes, pardon me, because when you're doing like kinetics and you want to do the rate constant, the College Board really likes students to know what the unit is. But in this case, they'd have to figure it out. So this is pressure versus 1 over volume. So the units are going to be what? kPa times milliliter. Sorry. But that's going to be the value of the proportionality constant. So now the other thing that people like, that if you're not real familiar with graphical analysis is I want to create a report. I want my students to get this out and do something with it. If you a couple of thoughts here is we can have more than one graph on the screen if we want. So if we go to the top right and we pick the view options, but this time we pick data table, graph, and we turn on 2 graphs, Now, the other thing is, I don't really need the meter anymore. It's not necessary. I can turn that off at will. I don't really need, pardon me, don't need the data table anymore. So let's get that kind of cleaned up a little bit there. So, you can have whatever you want plotted on it on whatever you want. So on the top graph, maybe I want the pressure versus the corrected volume. So I can go and tap on the x-axis or y-axis and adjust whatever it is I want plotted. So there's the original plot. And then on the bottom one, I want the linearization. So you would tap on the axis labels, turn on what you want. So on the y-axis, we want pressure, and on the x-axis, we want inverse volume. Okay, so there's our data. And we can also have our curve fits individually. You can title these. So my students would lose a point if they didn't title their graphs. And so if you tap on the little graph tools icon for each graph and go to edit graph options, you can put a title. Bare minimum, especially with my lower level students, would be dependent variable versus independent variable. Yeah, it's no inverse. But you can see you can do all these kinds of things that you would potentially want your students to do. Any questions? Melissa, is there anything coming up?
Nope, nothing's come up yet, but you're doing such a good job of explaining everything.
Am I? I hope so. I hope it's useful. But yeah, this is one of my favorite experiments, mostly because of the simplicity of the setup. No solutions involved, and so it's a really nice experiment. Now, if you want to make a report, what you do is go to the file menu. While I'm in the file menu, let me make a comment. Those of you that are using Chromebooks, this save option and open option, be super duper careful. If the students are using their own Chromebook, that's fine. They default to the downloads folder on the Chromebook. And if it's their own Chromebook that they're always using every day, that's great. But if it's not, if it's a school Chromebook and they switch Chromebooks every day, you want to be careful that they save their data to their Google Drive. We get this call once in a while. My students did a titration and they can't find their data. It's because it's on the original Chromebook that they did the data collection on. And that's just part of Google and the way Chrome works. And so it's something to be aware of. Where did that data go? But as far as reports go, I'm going to go down to export. The free option of graphical analysis does, if you have separate graphs, it does them in separate windows. We are talking to the software guys about adjusting these data. I don't even know what that little doodad is, but adjusting these statistics windows, so you might be able to slide them around. There is some small adjustments you can do by changing the graph shape and so forth. These two options generate graphs that are PNG file format, which is super common. And you can save those. Or if the students, we were switching the last 3 years that I taught, we had no, I was teaching forensic science and we had no curriculum. I was basically writing it myself. And we were doing it all on Google because we were a Google classroom, school. And so what I did was I created a template to help the students to create reports. There's a cute little copy icon here, very, very handy. You can just copy the file, go to your electronic editor, whatever it is. What I did was I put a copy in here, I believe here it is, lab report. You're welcome to it if you want. It's a pretty standard. My ninth graders had lots of trouble, they would lose points for not having all the sections of their graph. So it's all, the standard lab reports and stuff, but here's graphs and data. And so, any editor, Word, Google Docs, this is slides. It makes a nice presentation. The forensic kids were once in a while they would have to make a presentation, so slides was a really nice way to do it. But that's built into graphical analysis. Now, not to say this is what I would pay for Pro, but this option for PDF will put both graphs into one file. So you can see it's one file there. However, be aware that the PDF option is only a Pro feature. And so right now you guys have Pro, you can explore it and fiddle around with it. I wouldn't necessarily buy graphical analysis just for this one feature, but it is kind of handy to have everything in one. I mean, of course, the other option is to just take a screenshot of the two graphs together, just depending on your operating system. There's different ways, but you could do a screenshot. I wanted to point out a couple more things about graphical analysis, and if anyone has any questions, please don't hesitate to just jump in and say, I put this in there so if you want to take this picture and show your students or something, just so that you would know why we have the adapt. In the original copy of the experiment, which I did share, it's right here, Boyle's, it's here somewhere, Boyle's law right there. It does tell the students to add in the 0.8. It's your call whether you decide, to tell them that or not. I think it's kind of amusing to see how much difference that little bit of volume makes. And of course, it's an inverse function, so that's part of the reason why it makes such a big difference. But I put in here, I put some resources that might be helpful to you. And then I think I put it in there. Let's see. I could have sworn I put a link to, features of Graphical Analysis Pro that you have it now and you guys can explore it. For example, if you look at the title page here on graphical analysis, this thing here that says see experiments, in the free version, that won't work. If you try to click on it, it'll say you have to activate. But if you've already got your Pro version activated, there's a number of experiment data files with videos, including the one we just did. So, you can go to chemistry and look at all the experiments that are in there for chemistry. And I know Boyle's law is in there somewhere. Let me see, there it is. And so we have the data in there. I believe, Melissa, you made these videos, didn't you?
Not that particular one, but I made several of the time-based ones, like the some of the crystal violet and the kinetics experiments we have. There is one with a gas pressure sensor that looks at the gas production from the hydrogen peroxide reaction. So there's several videos in there and this one's kind of not as interesting since it is events with entry. It's not actually synced to the data, but if you pull up one of the time-based ones, like kinetics one, we actually sync the video to the data. So if you're looking at the crystal violet reaction, you see the purple color go away over time in the video at the same time as what's happening in the graph. So makes it a little bit more exciting versus that one's just kind of a video in the experiment file, which is still really nice to have if you have students that missed a lab session, they were at a football game or something. It's kind of nice to be able to have some of that. You can also make your own videos and put them in with Graphical Analysis Pro. So it's definitely a nice feature.
So this came out of COVID, and what happened was that we were sharing data files for teachers because of many of the difficulty collecting data. And then the question came out, well, my students don't really understand what's going on. And so this ability to add video to your data files, it was added to graphical analysis. Now it is a pro feature, so you do have to pay extra to either see these videos like the one there that Melissa's doing for Crystal Violet, or add your own in. So once, so this icon here that Melissa put in there, let me pause it. That icon tells me that at that point, data is being collected. So it's, where was it, Melissa? I wasn't bad. I was talking, not paying attention. Let me look at the time here. Oh, it looks like it's already going. Okay, so it's before that. Oh, this little icon. Go back. So what I'm fiddling with and not doing a super great job of is finding that point where the experiment started. Melissa's mixing the crystal violet with sodium hydroxide, and so it's actually the reaction is starting, and then she's going to put it into the colorimeter. This could also be done with a spectroviz, but not in graphical analysis. So that's the reaction is now starting. She's putting it into the cuvette, and then let me pause it once we get that arrow. And that tells me the point at which data is starting to be collected. So that's at 51.94 seconds. And so if I do up here, if I put that time in 52 seconds, I guess that's close enough. And then let me speed this up a little bit just so we're not taking forever. So now what happens is that the data collection will actually be synchronized, and you'll notice that there is the absorbance dropping as the sodium hydroxide reacts with the crystal violet, and in the video the students can see that the color is dropping. This synchronization option is part of Graphical Analysis Pro, but only works with time-based data collection. So you can still put videos in for event-based, but you can't synchronize them like you can with time-based. And it actually follows, so it's a little hard to tell there, but you can see it's a lot darker, and then the data and the video is synchronized. So it's kind of a neat feature and something that you might want to experiment. Have your students import their own video. So if you set it, if you start with your own, let me trash this one. If you start with your own data file, you can import your own video, have your students take a picture of their setup, and then I hope that's it's not an appropriate video, but you get the idea. You can stick in your own videos. So that's something that you might want to look at. The other things that in graphical analysis, I had a teacher ask me, hey, can we convert pH to concentration of hydrogen ion to hydronium ion? And in the regular version of graphical analysis, it's really a pain. You have to do multiple individual calculations. With the Pro version, you can put in a custom formula. And so this function here, 10 raised to the negative pH, you can actually put that in. And so I won't say any, but a lot of the custom formulas that you might want to explore, you could do with Graphical Analysis Pro. You can also do custom formula fitting, but that's not something in chemistry that we do very often. And so, Melissa, did you want to show, if I get my screen up, did you want to show the little error bars thing?
Yeah, sure. We got time.
Yeah, let me get out of the way here. I'm turning myself off. The error bars is new, and I didn't teach IB, so I didn't really use it very much, and so this is something that I'm learning myself. And so Melissa, take it away.
All right, just making sure you see graphical analysis now, right? And
I see it.
Okay, cool. Yeah, so like Nüs said, this is a feature that, I think AP and IB would use it. IB for sure. I used to teach college chemistry. We would do this almost all the time. Anytime you're having students take data, you want them to take multiple data sets, especially with something like Boyle's law. Maybe you want them to calculate or determine the uncertainty that's associated with the sensor or with the experimental setup. There's various reasons you'd want them to do multiple trial runs and then calculate the average and then have them graph the average from the data set. And then the error bars should show the deviation, the error associated with your experiment. So what I'm showing here is nothing new. Nüs went through and showed you all how to do Boyle's law. All I've done in this file is I've taken 3 sets of data. And this file is also in that Google folder that we shared with you. And then it just has 3 sets of data. I went ahead and did the corrected volume calculated column like Nüs showed you how to do. And so all I'm plotting here is pressure versus corrected volume. And I have all 3 data sets plotted. So some of you might just be wondering, how did I get all those 3 data sets plotted on the same graph? Because it's a very common question. Again, anytime you want to change what is being plotted in graphical analysis in Vernier land, really, you click on the label axis. So if I want to just show one data set, I turn these off. And if I want to show all 3, I turn them on. And my goal in showing you these in doing these calculations with you is so that I get one line that shows the average of all these 3 data sets, and then the error bars should reach all that data, right? To show, and I tried to do a couple data points that were a little bit further off. So you can see like this one down here is going to have a lot of error. So it should have a pretty big error bar. So that's my goal. So to do that, actually, we have to do that calculation outside of graphical analysis. Graphical analysis can't do a calculation with rows. We can only do calculations with columns. So I need to export the data out of graphical analysis. And Nüs showed you some of those options earlier, but what a lot of people at higher levels want to do is export as a CSV. So I'm going to click export CSV. You don't get a preview of it, but that's okay. We all know what a CSV file should look like. And then I'm going to save it, and I'm going to find the right folder I want to put it in, and I'm going to save it there. And I'm going to open it in Excel. You could do the same thing in Sheets or anything like that. And I want to go to, I have to find where I saved it, right? Oh, PD Workshop, here we go. And then you got to look for all the CSV files. There it is, open. Okay, and now I have my file. So let me make it a little bigger so everyone can see the calculations I make. So this is how it's going to come in. You can see the data sets. So this is the pressure reading. This one here is the volume reading. This one here is the corrected volume. So all I care about is the actual pressure readings, because I want to take the average of all 3 of my pressure readings and then calculate that, and then calculate the error associated with that. So I'm going to make a column over here, average pressure, and then I'm going to call this one deviation pressure. So then I'm going to type in my Excel formulas 101. I want the average of these. And then I'm going to copy and paste. So it does it for all the pressure readings. And now I'm going to do the maximum reading here between the 3 pressures. And I'm going to subtract it from the minimum of these 3 pressures. And then I'm going to copy and paste down to get in all my data there. So now that I've calculated my average pressure and my deviation, I want to take this data and copy it into graphical analysis. So this is where things get fun. You can pick whatever data set you want. I like to pick data set 3. And then we did a calculated columns earlier with Nüs, but now we're going to just do a manual column. So I'm going to add a manual column. I'm going to call it average pressure. And it's in units of kPa. And I'm just going to leave that like that. And then I also want another manual column that is my deviation. Okay, so now I look and I see I have 2 empty columns. You'll also notice it did it to every single data set. All you have to do is copy the data into one of them. Okay, so I go back over to Excel, I highlight the data I want, I copy it, and this is also super handy for lots of different reasons, setting up a manual column and just being able to paste, oops, my bad. I did it wrong. You just want to click once, don't double click, and paste the data in. Oh, guess I have to do it one at a time. It worked with two at a time. I don't know why it's doing that. Okay. So I'll do one column at a time. And there we go. And I get all my data in. So you can copy and paste directly from Excel. And now I want to plot my average pressure. So again, I go over here and I see I have average pressure. I know I added it to data set 3, so I'm gonna close all the other ones. And so this is my average pressure. And again, I wanted to have error bars showing my deviation. So I'm gonna click this column options in the average pressure. Go to column options, and here we have show error bars. Why is it's not working? Show error bars. Well, that's not good. Why is it not letting me do this?
Your copy of GA is pro'd up, right?
It is, yeah. Right?
I assumed it was. Tap the TIE fighter, that'll tell you right away.
Oh, that's true. Yeah.
Yeah, you gotta
What happened? It also didn't copy right. Let me just delete this again and make sure it's copying right.
I mean, it worked great yesterday when we were trying.
I know. Hate when this happens.
Yeah, especially when you're demonstrating it. It's like,
oh, I know.
You know, okay, let's see.
The
option.
Yeah, I don't know what's happening.
It's,
Well, you know what? Let's just do it again. I hope it doesn't have something to do with the fact when I made this file, I deleted some things and maybe there's like a weird bug.
yeah.
We'll see. Add a manual column. Okay, we're gonna put in average. There we go. That should work now.
They look different.
Yeah. And then deviation pressure. I think it's because I tried to do 2 columns at once. We'll see. See if it fixes it. Okay, so let's go back, close all these, open average pressure. So now I have one data set on here. Gotta copy and paste my deviation. Okay, now I go into average pressure, column options, show error bars. Here we go, the magic moment. All right, so there's a couple different options that you have in here. You can use a fixed value. So if I know, for example, the error associated with my data might be this plus or minus 0.8 milliliters because of this error of volume in the cell. I could use that. I could use a percentage, but I went through all this trouble to calculate my average and my deviation from my data, from my experimental setup. So I made a column. So I'm going to use a column value that I titled the deviation. I'm going to select that and I say apply. And now I have error bars on all of my data. So hopefully you all can see that. There's a red dot. And then again, like I said, this kind of first data set has a large set of error. So that's where you see the really big error bar. The rest of them are kind of hidden because the error was so small. I can also change the color of that dot. And I can change the color of the error bar. So I can go in here and say, I really want everything to, I want the error bars to be way more obvious. Maybe I want to do like an open diamond and maybe do like a yellow, something like that. So you can kind of change to make them more or less obvious. I could make it darker. And then you can see it how you like. You can adjust some of the color there. So that is error bars in GA Pro, and that's one way that you could use them. Of course, there are lots of different ways to use them, but that's how you set them up. So I'm going to go ahead, and we have about 5 minutes left. It looks like maybe some questions came in.
That was me poking away there, talking about IB teachers and stuff, because that is for a long time, we've been having people ask about getting error bars into GA. We finally have it, but it is a pro feature. But you really helped me there with the data set, because there's an article on our website that talks about how do you determine the accuracy of a reading or a sensor. And the only way to really know it is to, is to run the experiment over and over again, and compare the values. And you just taught me how to do that, which I didn't know, And so I will I put it in the chat. I'll also add it to the slide deck, the link to that article about, repeating an experiment and that sort of thing. But yeah, that was very instructive for me. Thank you. I will be spending a little more time with that. But yeah, that's a cool application. So, but anyway, I didn't want to keep everybody. Let me just point out a couple of things. Just a little bit of housekeeping at the end here. There's a link in the slide deck to our webpage that does compare GA and GA Pro. So you can see, what are you getting for your $99 a year if you're a small school, under 100 students using GA at the same time, versus it's a little bit more if you're a larger school. And so this tells you, what the advantage is. I will tell you that almost every experiment can be done with the free version, but there's a few things that the pro version adds that are very nice. In the forensics book that we're working on, we have one experiment that takes advantage of some pro features, which you just don't have in the free version. You can run the experiment, you won't have those options. So, other thing I wanted to make sure you knew is that Melissa and I and Elaine are at chemistry@vernier.com. You can always call and talk to us. You can write to us, let us know what we can do to help you out. We're always available to you guys. We are on the West Coast. I'm not sure exactly where everybody is. David, I think you're on our side of the country. So just be aware of that. If you call or write email at 8 a.m. East Coast time, very unlikely that any one of us is gonna answer. So, so just be aware of that. But the link to the videos, I think Angie's going to send that out later this week sometime. So so if you need that, or I know some people need certificates for training and stuff, and so all that will be, I believe the certificate's actually in the shared folder, if I remember right. Anyone have any last minute thoughts, questions? Thank you, Randy. Well, I hope things are going well for you all. Early in the school year, we will have more chemistry sessions. We are trying to coordinate them with what we think is close to where you are in your curriculum. I know for me, Boyle's Law was relatively early in the curriculum, kind of a physical property of matter sort of thing. But if you have any thoughts, by all means, chemistry@Vernier, just say
yes, please send us your ideas for webinars. What do you want to hear?
Yeah, if you want something with spectra, or if you want something with I don't know, pH, we just did a pH one, but
the next one we're doing is going to be with the mini GC and how to determine the best temperature pressure profile for your data collection. So hopefully we'll see some of y'all there. But yeah, let us know what other ideas you might want to have, and we could plan those for the spring.
We would love to do that. As you can tell, I have a good time with this, especially when I have Melissa helping me out, because I get to learn stuff every single time.
Yay.
Okay. All right. Well, Angie, I think we're pretty close to done. So
yeah, thanks everyone for coming. We'll see you next time.
Okay.